Okay, good evening, everybody. So, Uma, now can you speak? So,
Yeah.
you're talking about a situation where laptop has Skype, and Skype has what?
Webcam.
Okay,
Or the laptop has webcam, and whenever the Skype is started, webcam will be started.
right.
So, should I create a different class as like we worked in object communication? I have to create a class for webcam, Skype, and then call those two classes in the main method laptop. Or should we create a main file like animal that you explained in inheritance? Should we create a main file, main class as laptop, and then create subclasses like Skype or
What do you
webcam?
think? What's your understanding so far?
I I think it should be an object communication, right?
Laptop and what is the other one?
Skype and webcam.
Okay, and then webcam, right?
Yeah.
So, what do you think is the relationship? Laptop has Skype and laptop has webcam, right?
Yeah. So it should
So,
be
laptop,
object.
exactly. Laptop holds the object of Skype and object of webcam, and your inheritance comes into picture when you have an easy relationship. Meaning,
Okay.
you have you have a laptop, right? Let's say within this laptop, what are the kinds of laptops you have?
Yeah, we can have different kinds of laptops, right? And that will come under inheritance.
Right. Exactly.
But when we work with when we work under object communication, do we need to work on constructors too?
Of course, everything is a constructive thing. There is nothing like a when you work on object communication. Do we work through constructor? That question itself is little. You know,
Sorry, I'm sorry.
no,
Okay.
That's okay. That's totally fine. But we have to think. So once we go there, what do I need to construct a laptop? What do I need at the time of the creation of the laptop? So that is what go in your constructor, right?
Yeah, for the laptop constructor is okay. Sorry, I should have been clear. For the Skype and for the webcam class.
Okay.
So when you call the webcam class in the Skype,
When you call webcam class in Skype, huh?
yeah.
Okay.
For example, if I log into Skype,
Okay.
I want the webcam also to be on. Unless I log into Skype, I don't want the webcam to be on.
Right.
Okay. In that case, when I log on the Skype and when I start the Skype, I want to call the webcam file.
Okay.
Yeah. I don't know. I thought in this way. I don't know whether everything can be created in the same file or.
I am not going to. I mean,
I
did
just
you
my,
guys
my,
did
my
you guys talk? Did
no
you
no
guys
no
talk about it?
No, we were working on a different example yesterday, but
Okay.
yeah, we will discuss about it tomorrow.
Okay.
But the thing is, my question here is when I call the webcam class in the Skype,
Okay.
should I still use the constructors, or how about the constructors over there?
I mean, it's not just webcam to Skype. Okay. That's what webcam to Skype, right?
Yeah,
So what are the attributes of Skype?
the functions you mean?
No. I mean, I think we are going back to day one now. Day zero, probably.
Oh, sorry. Like
No.
the Skype has on and off,
Those
like
are
log on and
functions.
log
I'm
off.
asking about attributes.
Is there any different word used for attributes?
Hmm.
Like
Okay. State, right?
State. Okay. If state for Skype, it has, basically an app, right? So it has a name
Okay.
and it has a type. Maybe that's all. I cannot think more about that attribute.
Okay. I mean, if we still have doubts on this one, then maybe something wrong. I don't know. I mean, I can't spend one, today,
Yeah, I
definitely.
understand.
So,
Skype has
yeah.
ID. Yeah, got it. It has an ID and it has a username and it has a password. Yeah, I got that.
Okay. Yeah.
Yeah.
So the point is, again, why are we having this question of should I have the constructor or not? When do we use constructor, right? What's the purpose of constructor?
Okay. We can have the constructor in each and every class, right? So when I call the webcam class in the Skype, I have doubt in calling the constructors. Maybe I will work in the class tomorrow and then I'll get back to you.
Okay.
If it takes.
Yeah. Let's do that.
Yeah.
Because once I start again, I think we'll not get out of that.
Yeah, I know. Whenever we have time, we'll discuss about it. But my main question was that when we call the constructors, when we call the constructors from webcam to Skype, we say new Skype, for example, Skype space Skype is equal to new Skype.
Right.
And
yeah, go on.
Yeah, and then we call all the constructors from the Skype or whichever constructor is required, we take it, right? So there I had a doubt. So,
What is the doubt?
if you have time, could you please give me I can quickly show that. Otherwise, we can discuss it later.
Yeah, can you guys discuss?
Yeah.
Is that okay? Yeah.
Yeah, it's fine.
Okay.
But the thing is, we have to work with object-to-object communication, right? That's what I meant.
That's right.
So
That's right.
And when we work on object and how we have to work on constructors, we have to work on that. Okay.
Yes. That's right.
Yeah, thank you. Yeah.
The reason, I'm sorry, I'm a little rushing because once I start on this again, I'll go into that mode. So, yeah.
Sure. I know that. Sorry, but I just wanted to.
No. That's totally fine.
Put it in parking lot. Yeah. So.
Yep.
Yeah. Sure. Thanks again.
No problem. I know. I jumped on it. I jumped the gun. But it's we'll spend time on Saturday when you guys join. Probably I'll also be there for an hour. I can join the group, then let's discuss about it.
Sure.
But the concept is, but one thing I wanted to make it clear though. We have a has a relationship and is a relationship. This is inheritance. Okay. So this is inheritance. Okay, so your laptop has a Skype, laptop has a webcam, but laptop is not a Skype, laptop is not a webcam, right? So you have, let's say you have a class called computer, and then probably you have, not probably, now you have laptop, you have desktop, and you have your supercomputer, laptop, desktop, and then probably your smartphone is one of them, right? Smartphone is also a computer, and then your tablet is also a computer. Now this one, you can say a tablet is a computer, smartphone is a computer. So move all the common functionalities into computer, and then so that every computer, every type of computer, whether it's a desktop or laptop or smartphone or tablet, every computer type will inherit those functions from computer. Agree?
Yeah.
But we don't have this kind of relationship in your laptop and Skype, right?
Yeah.
Agree?
I agree. Yeah.
Yep.
Even I was working with
and now,
object.
And now from the constructor's perspective, I'm sure, so if you don't know whether this one comes with an experience, so what you do to start with, always think, try to think right, try to do the right thing, like what should my constructor be? So you can have a default constructor that is provided by the compiler, and you can have all the getters and setters. That's the most basic thing you can have it, right? You can definitely start there and then start thinking about it. Hey, can I change it? Ask yourself, can I change a laptop make? Can I change a laptop model? Can I change my webcam? Okay? Once you think that, no, this one can't be changed once it is a constructor, then move that to constructor. That's the fundamental way to think.
Okay.
Did you get it now?
Yes, yeah, I got it.
I know I didn't answer straight, but that's how we have to think.
But you have given me an idea, right? So I can work through that.
Okay. Yep. Thanks, Jyoti. They will. So, did you all meet yesterday?
Yes, we did.
Okay. Wonderful. So, are they helping those sessions?
Definitely. Yeah. At least for me, I know everyone is pitching in and everyone is helping. So
No, I'm sure they are. By helping you, I'm sure they are reinforcing their concepts. So no, don't worry, don't feel that way. Okay, very soon you will start helping them. So
okay, thank you.
that's all it takes. With the way you are doing,
Actually, Venkat.
Go ahead. Hello, Jyoti.
Oh, sorry, actually, Uma is really good with the requirements. So she comes up with the requirements, and based on that, we are developing.
Right.
Then
No,
we are exchanging.
she's really working hard on that. It's another few more days, probably another week or 2 weeks. You work like this, Uma. Very soon, you'll be able to help others. So good. Keep doing the great job, yeah. Okay.
Thank you.
Yep. No problem. So in the previous class, we talked about inheritance, right? So in inheritance, we talked about the concept that if you have is relationship, you can keep all the common attributes and common functions in the base class or parent class, and then all of your subclasses or child classes will automatically inherit from your parent. That is what we talked about. Now, you have some standard behavior here. We talked about this animal example, right? So animal, and then let's say dog, cat, elephant, and something else, rat. So we have eat, walk, run methods probably here, because every animal should be able to eat, every animal should be able to walk. So by default, when you say dog extends animal, you are getting the default behavior. You are automatically getting the behavior from your animal class. You don't have to do anything. You're already getting those methods, eat and walk. The question is, what if you don't like? Meaning, you directly inherit eat and walk methods in your dog. Okay, this is good for 90% of the animals. Okay, cat, elephant, rat, and other animals, they're eating, or let's talk about eat. They're all eating one way. But dog eats differently. I don't like the eat method that I inherited from animal class. What do I do in that case? Are you forcing me eat this way just because you created a generic eat method? So you're asking every animal to eat that way? Well, that's good for 90% of the cases. That is why you put them in the base class. It's a good design. But what if dog eats differently? In that case, whatever the behavior that you got from your parents, if you don't like it or if you want to do it differently, you can override that. You can override that behavior, meaning you can change that behavior. And that is going to be applicable for that specific odd case. And all the other animals will be eating like how animal does in your parent class, however you define in your parent class. But you are overriding in your dog class, meaning you are changing the behavior that you got from your parent. This is called overriding. And those methods that you inherited from your animal class, you'll be overriding them, right? So that is called method overriding. That is called method overriding. So what happens is, how do you override? So whatever the exact method that you don't like the functionality that is coming from your parent class, you use this exact same method signature. You use the exact same method signature and provide the functionality in your subclass or in your child class. That's it. For that particular method, your specific method functionality will be called. Meaning only for a dog, the one you overridden will be called. For all the cat, elephant, rat, everybody, your whatever the functionality that you're getting from animal will be executed. I'll show you with an example. So I'll take the same inheritance. Now, animal, right? In animal class, you have walk, eat, etc., right? Let's say you're automatically getting your eat and walk. So if you look at here, eat and walk, you're automatically getting it, right? So if you look at it, Tommy is eating, Tommy is walking, etc. But let's say that the dog eats differently than other animals. Then what we will do is, let's go to this animal class. So by the way, what I did here is that I pressed the control button or your command button in your Mac, and then press it here, and then you mouse over, then you'll find it. And also your F3 will work. F3 will also work to take you to that particular class. So this is the eat method, right? Public void eat. So what you do is, you use the exact same method signature. Again, method signature is your method name and all the arguments and in its order and the types. Okay? Your return type is not part of it. So your return type can be different. Okay? So take the same method signature and put it into your dog class. And now you say that, okay, now you say that dog eats differently. So I'm overriding. So whatever the eat method that you are getting from animal class, you don't like it. So this is the functionality, right? Whatever the name, Tommy is eating, that is what we are supposed to get it. But now we will not get it. If you look at it, now we will not get it. Dog eats differently, so I'm overriding. That is what is happening in the case of dog. But in the case of cow, your cow is eating. So cow got the eat functionality from animal, but dog also got the eat functionality from animal, but dog did not like it. In case dog did not like the functionality coming from the parents, then you can override public void eat. You have to have the exact same method signature of your parents. So here in animal you have eat, okay, and then no arguments, eat, no arguments, and then you have your method body. You can override it. So, but one thing that one thing with your access modifier is that when you override a method, you cannot reduce the visibility. Meaning, if it is protected here, in your subclass, you can make this public. But if it is already public, then you cannot make it protected because you are reducing the visibility. Cannot reduce the visibility of the inherited method from animal. So you can bump up the visibility, but you cannot bump down it. Agree? So from animal, you can if you happen to have this method as protected, you can make this public. So either keep the same access modifier or give more visibility. You can give more visibility, but you cannot give less. That's just one rule. Okay, so this is called method overriding, and one of the most popular interview questions is that what is the difference between method overloading and overriding? Okay, overloading and overriding. So overloading comes into picture when you want to use the same method name. You have the same method name but different method signatures. That is called method overloading. Overriding comes into picture in the context of inheritance. If you don't like the functionality that you're getting from the parent, then you can override it or you can modify it. And you need to make sure that the method signature is exactly same as your parent. Okay? And in fact,
and we should have the same return type as the parent method, correct?
the return type is not part of the method signature, so return type can be different.
Okay, so only the method name and the order of the arguments and the type of the argument.
Right. I'll talk about the return type probably little later.
Mm-hmm.
You can have the subclasses of the return types, etc. We'll talk more, in depth about it later. But okay, your method signature has to be exactly same, and you cannot reduce the visibility of that particular method's access modifier. And then, in fact, in JDK 5, okay, current version of JDK is 8, right? So, but in JDK 5, about this was released about 10 years back, I think. Yeah. So in JDK 5, they introduced for this method overriding, they introduced something called an annotation. So on this top of method, you can put at and then control space bar override. So when you put this annotation, what happens is, if your intention is to override something, and let's say I thought that eat is taking some food, okay, string food, okay. Now you said at override, that means you are telling compiler that this is just for utility, you are telling compiler that, hey compiler, my intention is to override something from my parent. Okay, then it will immediately slaps you back and say that, hey, the method eat of string of type dog must override or implement a super type method. Meaning there is no method eat with string. There is no method as such. Okay, there is no method like this. Your compiler itself will tell you. And before JDK5, we did not have this. This is called annotation. We'll talk about it later. But we didn't have this annotation. People like me used to run into a lot of problems because your compiler, if I don't have this one, right, your compiler thinks that this is a different method. So you have two different methods. One is eat no arguments coming from animal, and now eat string that you provided on your own. They're two different methods in dog class. But your intention is to override it, right? But you put something else. Are you getting it? So once you override it, your compiler will help you keep the method signature same. That's what your at override does. If at all your method signature is different, if you put your at override, your Java compiler is going to tell you that, sorry boss, your intention, I understand your intention. Your intention is to override a method from the top class, but I don't see a method with that signature. So maybe you typed it wrong. There is a typo. Fix it. So always use this annotation on top of the method that you are overriding. Make sense? Any questions so far? This is one of the most popular interview questions. What is the difference between method overloading and method overriding? Yes, Soma, we can modify, and that's what is called method overriding actually. Good? Now, okay, now, so that is about method overriding. And now, actually let's spend a little more time on overriding. Actually, let's get back to this inheritance demo, right? Okay. You have this dog equal to new dog, Tommy, etc., right? But I wanted to say something here. Let me this is going to be a very, very important and very interesting topic now, the one I'm going to talk right now. Now let's see. Animal A are equal to new. Come on, what's happening today? New dog. I have this one, right? Look at this one. Animal A equal to new dog, Tommy, 1.54 pitbull. So far we never did it like this, right? All these while we are doing dog D equal to new dog or animal A equal to new animal. That's what we've been doing. We never did this animal A equal to new dog. Did we? We never did this one. We have never seen left-hand side and right-hand side being different. Well, they can be different as long as they have inheritance relationship. So your left-hand side object has to be a super type of the right-hand side. So what do I achieve here? Well, take a look at this one. Did we have a dog method? So dog has a different method called getBreed, right? And the dog inherited methods like eat and walk from animal, right? So now when I say a dot getBreed, there is no getBreed method in animal class. There is no getBreed method in animal class. That's very understood, right? It's very simple. But when I say a dot eat, yes, there is a method called eat in animal class. Right now, there is a method called eat in animal class. Or when I say a dot walk, there is a method called walk in animal. But I could not call the specific method inside dog getBreed method because there is no method on animal. So this is the important point that we need to understand. Even though you call eat and walk method on animal, your JVM at runtime finds out. What do we think at this point? We assume that eat method in animal will be called, right? Or walk method in animal will be called is what our expectation. But no. Eat method in dog class will be called. Walk method in dog class will be called. Sorry. So your eat method and walk method will be called from the dog class, not from animal class. So what JVM does is, it does not look at what type you are calling your method on. Rather, it actually looks at what is the real type on the right hand side. So it calls the method based on the real type. So what we are saying here is that on the left side we are saying it's animal. Okay. So you can pass this animal to somebody else too. Now you can pass this animal object to somebody else too. But when you call animal.eat or animal.walk, what JVM does is, JVM does not check, hey, what is your type? Your type is animal. Your left-hand side, your type is animal. JVM doesn't care about the left hand. What is the real type that is actually instantiated on the right-hand side? So the real type will be checked for by JVM. So JVM will check for the actual type that is passed, and it will call the eat and walk methods on the dog. Now if you want to look at it, go ahead. See, dog eats differently, so I'm overriding it. So even though you called a.eat, it actually called the eat method on the dog class. Tommy is walking. The walk method, it has called and the dog class. Of course, dog does not have walk method, so it inherited from animal, so it ended up calling that one. So we need to understand this concept very, very, very carefully. So when method expects, let me write a simple private method. Let's say print animal information or something. Okay? And then I'm expecting an animal class. Okay? I'm expecting an animal class. Now, here this method is expecting animal class. Now let's say that this main method is calling this print animal info method, and now it is passing A, right? When you accept an object as your method parameter, it doesn't have to be the exact same type. It can be any of the subtypes. It can be any of the subtypes. So you can say dog A equal to new dog, and you can definitely pass it. See, hey, this guy is expecting animal object, but how am I able to pass this dog object into this one? Well, you can pass animal or any of the children of animal. You can definitely pass it. So what it is doing, this particular method, what it is doing is, now let's say that animal dot eat, right? Depending on the actual type that you passed it to me, I may be calling dogs eat method, I may be calling cows eat method, I may be calling goats eat method. So my method, this print animal info, is behaving polymorphically based on the type that I provided. So it is behaving polymorphically. What do you mean by polymorphically? Polymorphically meaning based on the context, it behaves differently. So if you pass here, I said animal, right? So now let's say that, now let's do animal dot eat and then animal dot walk. Here. See, dog eats differently, so I'm overriding Tommy is walking. So even though it is expecting animal, and here also my left hand side is animal, but my right hand side. So JVM always looks for the actual type that this object is pointed to, which is a dog. The actual dog instance has been created, not animal instance. Okay, now if I change this to animal A to something, right? Now if I say, I'll just animal A to, let's say, cow. Number of legs, okay. It doesn't have a breed, right? Now look at it. So your Tommy is eating and your Tommy is walking, meaning it's actually getting it from cow, but cow doesn't have these methods, so obviously it is getting from animal. So what my point here is that even though your left hand type is a parent class, okay, but when you call the actual method, the methods will be called on the actual type, not based on your type that you mentioned it on your left hand side. That is my point. Did you get that? So this actually is called polymorphism. So here Here, the print animal info, depending on the type that you passed, behaves differently. So if you pass dog into this one, you can pass dog. Okay, you can pass either animal or any of the subtypes. Always that's how it works. Either pass me an animal or any of the subtypes. But if you pass me a subtypes, now if you call cow, then I'll call eat and walk methods from cow. If I pass dog here, then now the exact same method is behaving differently based on the type, the actual type of the object reference. It doesn't care about this object reference here, but it actually cares about what is the actual type. Make sense? This is one of the object-oriented programming features called polymorphism. Did you get this one? Later, I will revisit this concept. Polymorphism is going to be the most important one of all. So once I talk about abstraction and interfaces, later I'll talk about the collections, probably in the next week or so. So then I will tell you how beautiful you can write your API once you understand this concept. Now, you may be asking one question, what is the advantage of this one? Well, if I expect a dog object here, right? If I expect a dog object here, you can only send a dog. Now you can only send dog. If you say dog A equal to dog, then yes, you can send it. But you cannot send any other animal. You cannot send cow, cat, or anything. But if you expose or if you have your methods take the super types, not your very specific type. Dog is a very specific animal. Rather than saying, if you absolutely need dog functionality of get breed, then you go ahead and expect dog. But if your functionality is very generic, if you're only talking about eating and walking, then by accepting the super types, you're coding for polymorphism. Meaning, if he changes his subtype, the behavior can be different. If he passes dog, you are actually calling the eat method of dog. If you call the cat, then you're calling the eat method of the cat. If you call the cow, then you're calling the eat and walk method of the cow. So that is why in all of your methods from here onwards, in fact, we are going to touch base on this one again in collections. Okay, and throughout my class, I will emphasize on this concept, polymorphism. Always code to supertype, code to supertype, code to supertype. That's a mantra. We will have it for the rest of the, I don't know, 2.5, 3 months. So when you expect any object, when you expect an object, always expect the super type if you don't need the specific functionality of the subtypes. Okay, Aruna, you said write once and use multiple ways. Yes. It's called polymorphism. So the object will be behaving differently based on the actual object passed at runtime. My point is at runtime.
Yeah.
See here, if you pass me a dog here, and eat and walk methods of dog will be called. If you pass me, I'm talking about the actual object being passed. See, my compiler has no issues. My compiler thinks that, okay, there is a method called eat, there is a method called walk, but the JVM at runtime will figure out, hey, what is the actual type here? Well, the actual type is dog. Then let me call the dog's eat method. Then let me call the dog's walk method. It's very, very, very
what I meant was,
go ahead.
Yeah, Venkat, just, what I meant was, if you use super type animal, it can be used multiple ways, whether it can be dog, goat, or whatever, that's what I mentioned. So.
Yep, exactly. That is polymorphism, Marina.
Yeah, that's what. Yeah, I didn't mention polymorphism,
Yep,
but that
exactly.
is right.
What you said is
You can
absolutely
use
right.
multiple ways.
Yes, yes. I mean, you can use multiple ways, meaning depending on the type that you passed, it behaves differently. I'm more comfortable putting that way.
Yeah,
It behaves
yeah, maybe. Yeah,
differently.
maybe I differently. Right,
It
exactly.
doesn't
Yeah.
do multiple things at the same time, but based on the type, it does only one thing at a time. It actually does only one
No,
each
no.
at a
What I
time.
meant was,
Got it. Go ahead.
yeah, same code. You can use multiple ways. That's
Yes.
what I meant.
You got it.
Based on the type you passed.
Exactly. Yep. So this can go ahead and talk here. Eat from override and walk from parent. Yes. So eat from override, walk from parent. Now let's talk about that one, right? Dog here. Eat you overrode and walk you're already getting from animal. Either directly, either you overrode or not, you are getting some functionality from your animal and some functionality you are overriding it. Walk, you are getting from animal. Eat, you are overriding it. Right? So both of them exist in dog class. Agree? Both of them exist in the dog class, either directly or indirectly. Here I'm overriding it, that's why I have directly. But walk method I'm already having in dog class because I inherited from animal. But here I'll be calling the eat method of dog class, this one. And also I'll be calling the walk method of the dog class. Since I don't have the dog, I mean, I have the dog, I don't have the walk method here in dog, but I inherited that walk from animal. So I have that walk here. Are you guys getting it? So that is what gets called. If I end up overriding the walk also, let's talk about it. Public void walk is what I'm thinking. Dog walks differently. See, here we're saying Tommy is walking, right? But dog walks differently. See now this walk method will be called. Now I'll execute the same code. So it is actually calling the dog's methods only, either directly or indirectly. But it is actually calling the dog's method, not the animal method is my point here. And you can pass cat object, then it will call the cat's eat method, cat's walk method. You pass cow object, then cow's eat and cow's walk method will be called. Make sense? Everybody got it so easily? This is a little.
I have a
I thought
question
it's
here.
okay. Yeah, go ahead. Uma.
First, I'm not able to understand this line, private static void. So far we have been using only public static void, main and string, right? This
Well, you can put it public. That's not a problem. I wrote a private method, a separate method. Forget about the static. We didn't talk about the static. So what I'm saying here is that we know the object-to-object communication, right?
Yeah.
Okay. Let me say, if you understand this way, we have the animals here, okay? And now I'm saying I'm creating a class called animal printer. Okay? So what animal printer does is it will print the information. Public void print. Okay? And now you give me an animal object. Uma, you give me an animal object and now I am printing the information, right? Animal dot eat and animal dot walk. Make sense? And now, agree? Now, yeah.
Yeah, see again here, public void print animal, right? So far we have been giving only parameters, and here we are giving animal.
This is the parameter.
Animal.
This is the
So
parameter.
animal is a parameter. Okay.
Exactly.
We can
This
use
is
animals as a parameter.
absolutely. I thought we did. See, like how you have
String,
used a
yeah.
string first name, string last name, etc. Similarly, string is an object, animal is also an object. Any object you can pass it, right?
Yeah.
Agree?
Okay, got it. Yeah. Got it.
So now in my overriding demo, forget about this one. What I'll do here is that animal printer equal to, I need to create an object of this one. Animal printer equal to new animal printer, and now I'll say printer dot print. And now any confusion here so far? Does that make sense, Uma? I instantiated this animal printer class,
Yeah.
and I call the print, and I passed this object here. See, I'm passing the animal. Now tell me one thing. This animal printer is expecting animal class, right? Can I do like this? Dog d equal to new dog. Can I do that? How can you pass a dog when this guy is expecting animal? How can you pass a dog when animal printer is expecting an animal? Any of you?
It's a subclass. Just now you said that it will accept everything in the subclass.
Absolutely. So when I say print animal or print any object, right, what it means is either you can pass me this particular object, or you can pass me any of the subtypes also. So children, grandchildren, great-grandchildren, anyone in the hierarchy. Agree? Any confusion here? Are we clear on this one? But my point is, see here. Now you can say the animal printer class. Think of this animal printer class. I want you to think about animal printer here. This is the most important one. By not accepting dog here, I can accept dog also. If I accept
Twice, but not Venkat. I don't know what's the problem.
Hello? Hello?
Yes, Venkat, we lost you in between. Yeah, now I can hear you.
Yeah.
Hello, can you hear me?
Yes. I can hear you. I'm sorry about it. I don't know. For some reason, it just went into sleep mode. Okay. So I wanted to think about this animal printer class. In animal printer, in the print method, by not accepting dog, I'm making more flexible code. Actually, if I put it dog here, right? So what I'm saying is, you give me a dog, I'll print the information, what it is eating and what it is, how it's walking, etc. Right? So this works good for all the dogs, but I want this method to be so generic that I should be able to pass any of the subtypes. Then expect that super type, which is animal. Now, this print method is accepting animal object, meaning either animal or any of the subtypes can be passed. Now you can pass your cow too. Animal A equal to same, see? Or you can do cow, doesn't matter. You are passing either cow or animal, but it is not going to look at what is your object reference type. It's rather going to look at the real object that is on the right side, the real object. Now, this is cow's methods. Agree? So this is called polymorphism. Okay. Any questions? We'll talk about it. And by the way, this kind of coding is called code to super type. Code to super type. And this is an excellent principle. This is an excellent principle called code to supertype. So always or whenever possible, expect the supertype, not the very specific type. So accept the generic type. Okay? Accept the generic type so that your class do not have to be changed if something else needs to be. See, rather than, see, you have few methods like this, right? You have a public void print. You can say dog. Okay? One for dog class. I can write one more method for cow, one more method for cat, like that. Or why should I do that? Actually, I can make use of this polymorphic behavior. So I'll just write, I'll code to the super type and you pass me any of the subtypes, and then based on the subtype, these methods will be called, not based on your object reference. That's the beauty of it. So that's about method overriding and code to interface, code to super type. We didn't talk about interfaces, but code to super type. Now, let's say earlier we had this example, right? Yeah. We had this example here. So from animal, you are getting eat and walk functionalities, and then only dog ended up overriding it because dog eats differently, but cat, elephant, rat, and all the other animals eat. They like whatever the functionality that they got from animal. Now, let's say, what did I say here? 90% of the people or 90% of the subclasses like they like the way, they like the eat method that they inherited from animal. Let's say it is reverse. Let's say it is reverse. Then let's say you know for fact that every animal has to be able to eat and every animal has to be able to walk. You know every animal should be able to eat. Okay, you give food and it eats. Every animal should be able to walk. So you know that these functionalities should exist in your superclass. But the point is, not every animal eats same way. I want you to understand this very carefully. You know for fact, you know for 100% that every animal should be able to eat and every animal should be able to walk. But how it eats differs for each animal. How does an animal eat? So dog eats one way. Here we have 90% of similarity. That is why we put the functionality in animal. But what I'm saying is, you don't have 90%. You hardly have the situation that or you have the situation that no two animals eat the same way. But you know that every animal eats, but you don't know how. That depends. Dog eats one way, cat eats other way, elephant eats another way, rat eats another way. So everybody eats differently. In that case, if you provide some basic functionality in your animal, everybody has to override it because they don't like the functionality that they got it from animal. Because you can't put some common functionality in animal because there is no commonality there. There is hardly any commonality. But what is common here is that you know for a fact that animals should be able to eat. And every one of the subclasses should provide their own way of eating. But in animal, you want to say that animal eats. That's all you wanted to say. You want to say that animal eats. So every subclass must provide how they eat, must provide the implementation to the eat. And this concept is called abstraction. And this concept is called abstraction. This is called abstraction. Abstraction meaning you don't know for real. Abstraction is like a myth, right? So you don't know for real. You don't know how they're going to eat. But you know that they have to eat. So you only provide the method signature in the superclass, but you do not provide how it gets implemented, and that will be provided by the subclasses. So in your animal, you will only say that public void eat, and you don't provide any functionality, no more functionality here. If you put it this curly braces, you have to write the code, right? How it eats, but you don't know how part of it. All you know is it has to eat. And let dog provide how, let elephant provide how, let cow provide how, let the individual classes, let cat provide how. Because they're all eating differently. If there is a commonality, let's say that they all walk similarly, then go ahead and put the whole walk functionality in all of them. Go ahead and put the walk functionality in animals so that every subclass will inherit it from the parents. But the point with eat is that every animal eats differently. So I only know that every dog must eat. In that case, not dog actually, every animal must eat, and only the method signature is same, but not the functionality. In that case, you are not providing any functionality in your super type. You are not providing any functionality in your animal class. You are just providing the method signature. So you are keeping that very abstract because you don't know. At the time of designing an animal class, you don't know because every animal is different. Let the subtype or let the child class provide the implementation. And this is called abstraction. Let me show you how we do it. So okay, now I'll get the same animal. So all of this is good. Walk is good. Eat is good. The other getters are good actually, but we are saying eat is entirely different, right? So we do not want to provide any functionality, but all we want to do is we want to provide the method signature. And if you do not provide the method body, this is called method body. Whatever you write it inside these curly braces is called method body. If you do not provide the method body, then you need to declare your method as abstract, public abstract void eat. Meaning, hey, I only know that every animal has to eat, but I do not know how. The how will be provided by the subclasses. They should know. Every animal, meaning every subtype of this animal, should know how they eat, but I do not know. I'm providing the full functionality of walk. I'm providing the full functionality of get name, get age, everything, but I'm sorry, I do not know how they eat because every animal eats differently. And if you have an abstract method, even if you have one abstract method, you need to put your class also as an abstract. You need to declare your class also as abstract. So you have to put this abstract keyword at the method level because you just provided just a semicolon, not your usual method body. You don't have the method body, right? Because you don't want to, you don't know how animals eat. Every animal eats differently. So that is why you have to put abstract here. And if you have an abstract method, then your class also must be abstract. By saying class is an abstract, meaning I'm not complete is what it is saying. Hey, I'm not complete yet. My functionality is not complete and you cannot instantiate me directly. You cannot say animal A equal to new animal because I'm abstract. Because there is an abstract method called eat, right? There is an abstract method called eat. Animal A equal to new animal. Okay. Name, age, do we have? Okay. Name, age, height, and number of legs. Okay. So you can't do this one. You cannot instantiate your animal class. You know why? Because your animal class is an abstract class. What do you mean by abstract class? Meaning that is not complete yet. Because what happens if somebody calls eat? What should I do? What should JVM do? Tell me, there is no functionality for eat because we said that eat will be provided by the subclasses. That is why your compiler does not even let you instantiate your abstract classes. So it is not complete. See here, cannot instantiate the type animal because that is an abstract class. So what do you want to do now? Animal is abstract. So what should you do now? Any of you? Any of you? What should we do now? Okay, Uma. Madhavi.
Yes.
So what do you have to do now?
Child classes will override for the eat method.
Exactly. So now you have to have a child class because this eat will be implemented by the child classes, right? Yes. So what you have to do is now you say dog, okay, and now you can say superclass here itself. You can say, okay, see here. Now public class dog extends animal. So yeah, you don't have the super constructor. So let's put it. Okay, and then okay, let's leave that way. Now look at this public class dog extends animal. Now it is dog's responsibilities to provide the implementation for eat, and now you are overriding the eat. Okay, in fact you are providing the functionality for the first time for eat. Okay, now you say that dog eats dog way. Okay, now if you provide your cat, right? See, I'm having the constructor here, and then this is the eat method. So you must provide, see, all these while we are talking about, when I talked about method overriding, you can override if you do not like the functionality coming from your dad. But here, you have no option because you are not getting any functionality from your dad. From your parents, you are not getting any functionality. So you must provide the implementation, or you must override it. You must override eat method. Agree? Because that is an abstract method in your top class. So cat eats cat way. Make sense? And now in your abstraction demo, you don't have to say this animal A equal to new animal anymore. You just say that new animal A equal to new dog. And then you say A dot eat, A dot walk. Now you look at it. So dog eats dog way. Tommy is walking. Make sense? So again, it depends on the actual type here. The actual type is dog, so obviously it will call the dog, and it will call the dog's eat method, and it will call the dog's walk method. Okay, but dog's walk is nothing but animal's walk. That is why it said Tommy is walking. Make sense? Did you understand the difference between the first and second one? First time, 90% of the animals eat one way. That is why we provided common functionality in our top class. We provided the common functionality. If any odd guy is out there, they will override. Java is providing a way to override. You don't have to. I'm not forcing you to take the functionality that's coming from your dad. You can definitely override if you don't like it. But now the scenario is reversed. Since almost 90% of the animals eat differently, there is no point in me providing it and you overriding it. I will make it abstract. By making it abstract, and I'm making it very clear to the public that, hey, this class is not complete. This class is actually abstract. You must override it. You must actually extend this animal and then override the abstract methods to be able to use it. Because you are saying that, hey, I can provide the functionality. I can provide the functionality walk. I can provide all other functionalities. But when it comes to eat, I can't provide. The reason is every animal eats differently. So I can only make it abstract. But I know that you may be wondering, why are we providing eat here? You can safely remove this guy and let dog provide separate eat, let cats provide eat. You may be wondering, why are we doing this at all? Why are we even providing the method signature? What is the importance of it? Well, the importance is that the fact that every animal should eat. And by providing this method signature, every single subclass, that every single subclass has eat method now. Now I can use the polymorphism. I can use the polymorphism here. Animal A equal to new dog and A dot eat. The reason I'm able to call this method an animal class is because I have a method at least as an abstract. If I don't have this one, I'll not be able to do it. I have to do a specific one. Dog D equal to new dog and D dot eat. So I'm coding to the subtype, which we don't want to do it, right? And also, we want to provide one unified interface to all the animals. Meaning somebody may take eat string, somebody may take eat int, somebody may take eat double. So somebody may call this method eat something like feed or something. So it is very confusing because every single implementation is calling that method in their own way. Are you with me? So when I use dog, I have to call this method. When I use cat, I have to use the other method. So I can't use the polymorphism there. But if I have the standard method in my superclass, I can use the polymorphism because I'm using animals classes eat method. So anyway, the actual eat method will be called based on the actual type provided on the right hand side. I agree with that. But compile time itself, I'll not be able to use this method if I don't have animal at all. That is why we are providing a standard interface for all the people, for all the animals. We are saying that, hey, I know every animal must eat. The only fact that I don't know is how part of it. I don't know how part of it. How part of it will be provided by the subclass. And that is why I'm only providing what part of it. I'm saying animal must eat. But by saying abstract, I'm saying that I don't know how this abstract will be implemented, or this eat method will be provided by these subclasses here, dog and cat. Agree? So when you're designing your classes, you find the functionality. If you think that, hey, 90% of the functionality or 80% of the functionality is standard across all the subclasses, go ahead and provide the default implementation. Those odd guys, the 10%, 20% people, they will override it. But if you think that, hey, I know that every laptop has to turn on, but every laptop turns on differently. The mechanism is different, the how part of it is different. But we know for a fact that every laptop has to have the turn on function. In that case, provide the method signature and make it abstract. Meaning you are saying that, hey, I'm providing this method signature so that the whole users of laptop can call that the turn on function, turn on method. But the actual turn on will be provided by the subclasses of laptop. Make sense? It's tricky. At least I'm thinking it's a little bit tricky, but you have to ask me more questions so I'll elaborate to any extent. Are you guys getting it? Can we talk for some time? I want to make sure you're... Rohit, how are you? You're so silent. Lena, you want to talk?
Yeah, listening to it.
Are you getting it, Rohit?
Yes, Venkat.
No questions at all? Okay.
Maybe
That's good.
Once more into coding, and then maybe in the next class I'll ask you.
Definitely. No, I'll feel very happy about it. But nobody is talking at all, so that's why I was little. Uma,
No,
let's
I
talk.
have a question.
Yeah.
The method is abstract, then why class is abstract?
Good point. Very good point. Let me answer your question first. Can anybody answer the hard question? When a method is abstract, why are we declaring a class itself as abstract?
Because the class.
So the whole class is incomplete. It is.
Exactly.
Sorry.
Go ahead. That's fine. Go ahead, Uma.
Basically, the class animal, when you call, when it is called by another class called dog or something, you should know that the particular class completely is abstract, so that you don't. Basically, you understand that you have not implemented defined any method. You just declared that. So basically that's the purpose, saying that the class is abstract. I mean, if you don't write an abstract, obviously you will think that it's a normal class itself. I mean, basically a general class as we write every day. But when you write it abstract, you can't even, basically the methods are not defined. So obviously you'll come to know you can't, like, you have to define your own methods, and they're just declared over there in that particular class.
So, thank you, Rohit. That's good answer. So, Madhavi, I'm just throwing with an example here. See, if I don't provide abstract here, right? Okay, someone like me tend to instantiate it. Hey, this is like a regular class, so I'll do animal A equal to new animal. When I say A dot eat, what do I get? Eat is an abstract, right? Eat is abstract. There is nothing. So you can't let me do this, right? So you can't let me instantiate it in the first place. So there should be a way to tell the public that, sorry boss, this is not a regular class, this is an actually abstract class, so you cannot instantiate. Abstract classes cannot be instantiated because there are abstract methods. There could be abstract methods, right?
Okay, yeah, I got it now.
So that is why abstract classes cannot be instantiated. But there is a small rule though. Small, what do you call? Yeah, rule. Even though you don't have any abstract methods, even though you have 0 abstract methods, you can still declare your class as abstract. Your compiler does not complain. The reason you want to do that is, let's say your class is not finished yet. Okay? You don't want people prematurely go and use it. Meaning you don't want people to go and instantiate it and call this, because for future purposes, for future design extensibility, you can definitely declare your class as abstract so that it cannot be instantiated. If somebody wants to use this animal class, then what should they do? If a class is abstract, how can you use it? Can one of you tell me? If a class is abstract,
basically if you want to add like more new methods to the particular abstract class, I'll just define it there, and the class which is extending to it, I'll declare complete. I mean, I'll be declaring in the abstract class, but I will be defining that into the class which is extending that.
I think Venkat Krishna said it right. So let me put it this way. If I give you an abstract class, okay, and ask you to use it, you can't instantiate it, you can't do anything. The first thing that you need to do is you need to actually extend.
You have to extend it.
Exactly. You need to extend that particular class and provide the functionality for the abstract methods, and then they can be used. Okay. Let me read all the comments or questions here. So we'll take it one at a time. Lena, you have a question. So why don't you go first? Yeah, I'll talk to Anuma. Can you remind me? I'll explain about the polymorphism. I know that's a tricky concept. Lena has a question.
Yeah.
And Yuri, basically if we cannot provide a definition for a method, we have to declare it abstract. It's not a definition. I wanted to correct it. If you don't want to provide the method body or method implementation, you call it method body or method implementation. If you're not providing this one, essentially what I mean by that is if you're not using these curly braces, this is in the curly braces, this is a block of code, right? This is where you write actually the actual code for your method. So if you don't want to provide it, then you must declare your method as abstract. And if you have one abstract, at least, or if you have an abstract method, then you must declare your class as abstract. There is no if and buts. Your compiler will force you to declare your class as abstract. Can we create an object of type abstract class? No, because you cannot instantiate it. You cannot instantiate an abstract class. If you want to make method abstract, it should be under abstract class. You got it. Because you declare your method as abstract, your compiler will automatically force you to declare that class as abstract. If you want to make a method abstract, it should be under abstract. Yes. Okay, now Lena, let's talk.
Yes, Venkat. Like, can we have any number of abstract methods in one abstract class?
Yes, you can have any number of abstract methods. You can have unlimited number of abstract methods. Okay? And
Okay.
you jumped one step ahead. That is my next topic, which is pure abstract class, meaning if a class contains only abstract methods. So you wanted to provide the interface, the common interface or a common API. I'll call, from here onwards I'll say API, meaning application programming interface. Application programming interface. When I say API, what I mean by that is the way to interact with the classes. So you have your car, right? How do you interact with the car? To start with, you will use your key. You put your key into that slot and then turn it. That's how you start it. Right? So that is the top level interface, because there is so much going on the moment you turn the key, there is so much going on, so many calls under the hood. Tens of classes will be called. Tens of objects will be called under the hood, but you're not realizing any of it. You're just doing at the top level. Okay? That is called top level interface or API, application programming interface, meaning how do people use your application? Okay? So I'll get into that pure abstract class in a second, but my point here is that you can have as many abstract methods as possible. But if you have at least one abstract method, then you must declare your class as abstract. But even though you don't have any abstract methods, you can still declare your class as abstract. Why would I do that? Well, you don't want anyone to instantiate it because you are still working on your design, and then you want everyone for the future purposes. So you want everyone to subclass and use it. You don't want anyone to use your class as is, then declare as abstract. They can't do anything. They can't instantiate it. Agree? Lena, did I answer your question?
Yes, Venkat.
Yeah.
Venkat, could you please repeat the one point I did not get, if there is no abstract, even though there is no abstract method, we
Exactly.
declare the class.
Exactly. So even though there are no abstract methods, you can declare your class as abstract. Okay? Why would I want to do that? Because if you declare your class as abstract, you cannot instantiate that particular class.
Correct.
Right? But why would I want to do that? Well, I'm thinking my class is not complete, and I will be getting some abstract methods soon. So I do not want anyone to instantiate it. This is for future design reasons. I do not want anyone to instantiate it. If somebody wants to use my class, they must. If somebody wants to use this class, they must. Come on, they must subclass it, or they must inherit. They must do an extends, and then they can use it. They can then instantiate it. Reasonable?
Okay. Yes, got it. Yes,
Okay.
thanks.
Ravi, no problem. Ravi, go ahead with your question.
Venkat, as per my understanding, abstraction is pretty much when we declare abstraction class, that means in future if we have to implement any other new methods for not disturbing the previous methods and using all the variables more efficiently, right?
Not really. No, that's not what I'm saying here. Let's say there is no abstract here, okay? Zero abstract. But still I declared this class as abstract.
Okay.
I may want to declare my class as abstract is because I do not want my animal to be instantiated. I do not want my class to be used as is. I'll repeat, I do not want my class to be instantiated, to put it differently. So I do not want anyone to be able to do this. Animal A equal to new animal. I do not want anyone to be able to do this. Agree?
Okay.
I do not want. So go ahead and at that point, what are my options? What is my option? Well, I will create a class that subclass this one. I'll create a class like a dog, and then I'll do a dog extends animal. And now I can do animal A equal to new dog. I cannot do a new animal, or I cannot do a new on an abstract class. I can do like this. This is not an abstract class. So I can do a new dog. But why would I want to do that? Well, for future design reasons, if I come back and add an abstract method, okay, I'm not breaking everybody because everyone is anyway, I'm not forcing everyone to change now, because earlier people were able to do this animal A equal to new animal A. The moment I introduce a new abstract method, everything will be gone now. Because once I say abstract, then people can't do this one, right? But for future reasons, to keep future into consideration, what I'm saying is, I don't want my animal to be instantiated. So I declare that class is abstract. Then I'm forcing everyone to extend it. Then when I introduce my abstract method here, since no one already instantiated it, there is less trouble. Agree? That is for extensibility reasons.
Oh, Venkat.
Yes, go ahead.
What I want trying to understand is if it's pretty much like why, if you declare it a private, it's a private class, then instead of, what is the difference between private and abstract then? Because you're protecting the class by by declaring it as an abstract class.
Right.
And you're telling that this particular class is being protected because I was declaring it. You can do it private, right?
We didn't talk about the private classes first of all, okay? But if you do a private class, okay, can anybody use the private class outside of it?
No one can use it.
Exactly. But here, people are using it. I want every functionality to be used, Ravi. I want every functionality to be used as is, but I just do not want anyone to instantiate my class. Understand this point here. So you can use walk method, you can use eat method, you can use get name, get age, everything that you are getting, you can as is simply do my dog, right? Let's say cat, right? Or cow. Cow extends animal. See, I'm not doing anything here. I don't have anything. Just doing public class cow extends animal. That's all. I'm not doing anything. Ravi, here
yes.
I'm using it and I'm inheriting every single method that is declared in animal class. I'm using it. I can override if I don't like the behavior in my cow class. Are you with me? The only thing that I can't
Yes,
do,
yes.
the only thing that I can't do is I can't instantiate it. I'm forcing everyone to extend this class and then make your judgment. Which method to be overridden or which method to you make the call. But you do not want to use my class as is without inheriting. Simple. Got it?
Yes, yes, Venkat. Thank you.
Yuri, I'll provide a lot of examples in the real life when we talk about collections. Okay, first let me introduce collections later. We'll talk a lot of abstract classes and interfaces. We will find a lot of them, tens of examples, so no worries. Let me explain one more time what is polymorphism for everybody. So the polymorphism is when I design a class. Okay. Yeah, go ahead.
1 second, Venkat. Can you please maximize this one? The font is too small.
Oh, it's too slow. Okay.
No, too small.
Yeah. I'll write here. Is that okay? This is okay, right?
Yeah, perfect.
Okay. Let me write here. Polymorphism. So when I design a class and especially method, right? Especially method. So I have this animal printer. Okay. Animal printer equal to new animal printer. Then ap.print. So this print method here can take dog object. I can overload this print method for a dog object. How many classes we have here? We have cat, dog, goat, etc. Right? So now here I can overload one for dog, one for cat. Okay. So one for cow, etc. I can do it like this. No, you pass me dog, I'll do it. You pass me cat, I'll do it. You pass me cow, I'll do it. Now, the downside here is that what happens if there is a new animal comes into picture? Let's say there is a class called rat. Let's say we did rat, okay? We implemented rat. Rat implements animal too. Then what do I have to do? I have to come to animal printer. Then I have to change this class to add one more method to provide the print functionality for rat class also, right? Rather, I do not want to code to the subtype. What I want to do is, I'll say, I don't care whether it is dog or cat or rat or tomorrow new animal. I don't care as long as you pass me an animal object. I'll print their information because I know these methods exist in the top class itself, and I'm only depending on the top class. I'm not talking. I don't need breed information. If I absolutely need breed information, then I will declare dog itself because that's specific to a dog. But this one is not specific to a dog or any animal. It is generic to any animal. It is generic to any animal. By doing this way, my design is extensible for tomorrow, meaning if you introduce two more animal classes, rat extends animal, beaver extends animal, these two are animals, then my print method will still work without having to come and touch this one. What is happening here is that by saying that I'm accepting animal here, okay, by saying that I'm accepting an animal here, what I'm saying here is that either you pass me either an animal object or any of the subtypes of animal. So the same print method, if you pass me a dog, I'll print dog eat, dog walk. If you pass me cat, then I'll call eat and walk methods on the cat object. You pass me cow, I'll call the eat and walk methods on cow. You pass me rat, I'll call eat and walk on rat. So the same print method behaving differently based on the type that is provided. The same function is doing more than one based on the type provided. So if you provide a dog, it is behaving one way. If you provide a cat, it is behaving one way. You provide a rat, it is behaving one way. You provide something else, it is behaving one way. So it is behaving differently based on the animal that is provided to you. So you are seeing the polymorphic behavior. Okay, so this is called polymorphism. Does that make sense, Uma?
Yeah. Thank you.
Understand it? Okay. So now we talked about abstraction. So Lena asked, hey, how many abstract methods can we have? Well, you can have as many abstract methods as possible. In fact, you can, if you say that I can understand it and getting confused as well. So don't worry. Actually, the whole collections API touches every single concept of it. Okay, there we will actually look at the actual interfaces, actual abstract classes, So all of these are the basic fundamentals, right? And we will work on them for the next few months, the next couple of months. Right? So no worries. All these objects, all these concepts will go into your bloodstream, so don't worry.
Venkat, I think you're confusing with this animal and animal. If you pass the cat, then you can create instance of cat so that it makes all of them understand very well, I guess.
Say that again. How do you want me to put it?
Here you are passing animal, right? Cat animal, dog animal in animal printer.
Let me, okay, yeah.
If you, instead of animal, if you create a class cat.
I didn't understand. So instead, you want me to put cat here?
Yeah. Now I think they're confusing with this animal. Instead, you put it as C or something like that, so that they'll understand.
Oh, you mean this object reference here?
Yeah. I think they're confusing with that.
I don't think so. I mean, this is just an handle to the object, right? This is just an object reference. I'm not sure, but if that's what the confusion is, then this can be anything. This is your name to an object,
yes,
right?
Yes, yes.
Oh, that's the confusion? Is that the confusion? Okay. Oh yeah?
Yes.
Okay.
For me, at least, I was thinking why we have two animals, and I was just referring to the previous examples and then trying to understand.
No, this is just the object reference, right? This can be anything. I can change it. I'll just refactor, rename.
The previous examples is like dog.
Yeah.
Good.
No, I'm
No,
saying
basically it's
it's an
saying
object.
as like
It's an object reference is my point. This is just a name of the variable. What type it is? Type is animal. Type is important, not the name, Uma. That's my point. That's all.
So Uma, for you to just understand, it's the same as the string array and args. What we will give, string is an object. So animal is also an object, and a is nothing but the argument variable name. That's it. You can give it anything.
Did we ever care about exactly what Jyoti said is 100% right? String name equal to Uma. What is the type here? String. What is name here? Name is a variable, right? So did we ever care about the name of the variable? It can be anything. You can say Uma, or you can say Venkat. You can say this is just a variable, right? This is just an object reference that points to the actual object. So here by saying animal A, okay, what we are saying is this print method is taking the object of type animal, and from here onwards I'll call this from here onwards I'll give it a name called A. So from here onwards I'll just say A dot eat, A dot walk. This is just an object reference using which I can call any of these methods, right? This is just a remote, Uma. Remote to the object. Remember we talked about it?
Yeah, I got it. Now I understand.
Sorry if that's what confused everybody.
See, actually in the previous example,
we will declare this method.
Sorry, go ahead. One at a time. You go first, Madhavi. You started.
Yeah, we will declare this method in a demo class, right?
We'll declare this method in the demo class. This one?
Yeah. In the main method, we will declare there public void print animal A.
No, this is actually inside the animal printer, right? This will be called by, see here, overriding demo. Here I'm calling the animal printer, and I'm passing an animal here, and I'm asking it to print. See, in object to object communication, I mentioned that the method arguments can be other objects too. Remember that? Maybe that's the confusion.
Yeah. Now, in the object communication, you said that.
Maybe I'll just step back for a second. It's okay. Let's step back for a quick second. What we'll say is, let's say there is a car, right? Car holds engine, right? Okay. And now, let's say when we start the car, okay, let's say we have an engine, we have, how do I say that? Let's say engine.start, okay. Let's say there is a method, and then let's say the start method takes something as an argument, some other object, okay. Let's say engine takes, lack of better example, spark plug, let's say, okay. Let's say the spark plug is part of the car, not part of the engine, okay. Your car will have both engine and the spark plug. And now when you say engine.start, your engine expects your spark plug. So I'm passing the spark plug object to the engine, and I'm asking it to start. So you can pass an object here in your methods. That's exactly what we're doing, right? Does that make sense? Everybody?
Yes.
So Venkat, I have this question, Venkat. You are saying a reference variable
of different types is pointing to the same object.
Reference variable, okay, slowly, reference.
Of different variable of different types. It can be animal type or dog type, but it's pointing to the same object.
You're talking about here?
No, in your polymorphism on the right hand side, let's say you put new dog, that is the object it is pointing to, even though on the left hand side it can have different types.
Absolutely. On the left hand side,
is that what you're saying?
No, the left hand side you cannot have a different one. You cannot have a car A equal to new cow. You have to have on the left hand side, it has to be
you are having animal
type.
A is equal to new dog.
Exactly.
You are having animal A is equal to new dog. You can also have dog A is equal to new dog. So it can have different types basically.
Absolutely.
But it's always pointing on the right hand side. Okay, got it. Kind of.
See,
yeah.
Cow A.
Provided it's the parent class.
Cow.
As long as it's a parent class and subclass, those are the types that is valid on the left hand side. Parent and its own class.
Exactly. Okay. So you
that means the animal can be cow or animal can be dog, animal can be goat, right?
Exactly. On the left hand side you can have animal A equal to, so this is the actual type, right? So this is what you will be passing, this is what your compiler will be using. I want you to understand this one. This is what your compiler will be using to see if there is a method exists in animal or not. But when runtime, when you are actually executing your bytecode, when JVM comes into picture, your compiler is nothing but your, it does some, it checks for your grammar, right? It will check whether print method exists in your animal or not, right? Or whether walk method exists in your animal class or not, or eat method exists in your animal class or not, right?
Right.
Right? That's all compiler does. But what JVM does is when you call this a.walk, okay, what JVM does is JVM does not invoke the method walk method on animal just because your object reference is of the type animal. It will actually look at the actual type that your A is pointing to. The actual object on the heap is a cow object and your A is pointing to the real cow. So your walk method of cow will be called, not the animal. That is my point.
And the reason you are making the type animal is because so that it can be used in
good point.
Across many classes. That's why you are making the type animal instead of dog.
The reason
instead of cow.
Good point. The reason I'm making on the left hand side always super type is because I can be polymorphic. Okay, so this guy is expecting in this particular case cow A equal to new cow and I can pass A. Okay?
Right.
Okay. But see here, the point is, if let's say cow has a different method called milk. So this is the dangerous now. Now I'm not using polymorphism. You know why? Because the moment I change from cow to dog, hey, dog milk is not there. So you can do a dog A equal to new dog, right? Now I'm changing the code because there is no milk method. If I absolutely need a milk method, I will use the cow on the left hand side. But if I'm not using any of the specific methods, if I'm only using the ones that are coming from the super class, then use animal A equal to new dog and your, what's this one? Okay, whatever, cat, right? So animal A equal to new cat. If you do this one, then your compiler itself is helping you that, hey, there is no milk method or anything. So I can only call the methods from your animal class. So what am I achieving here?
Wow, it's okay.
So
yeah, I'm achieving all the superclasses and all the subclasses. Everything I can capture, use it by keeping my reference variable as a super type.
yes, I'll tell you.
Okay.
I'll tell you more example. Understand, this is a very, very tricky concept. Even you speak to people with decent number of years of experience, they still get confused. So don't, I'll explain again in the next class also. So don't worry at all. Okay, see this one? My point is, I wrote these many lines of code. Okay? Now,
Okay.
I don't want to pass cat, I want to pass cow. How simple it is. Everything works just by changing my right hand side. From cow to cat. Did I change anything?
No, nothing.
But now, what is happening here? Walk method on cat will be called, eat of cat will be called, get age of cat will be called, get name of cat. It is actually calling based on the actual type that is out there in the heap. This is the actual object. Now A is actually pointing to the cat. Now change it to cow. Am I changing any of these lines anywhere? I'm not. Because I'm not using any specific methods of cow. But if I change my left hand side also like this, I'll be tempting to use milk, if at all. If I absolutely need to use milk, then I have no option but to use this way. But see here. So I'm only using cow now. The A is pointing to cow and my type is also cow. Let's say I want to use a polymorphism now. Let's say I want to do a cat. I want to do a cat here. See, you can't. So by using the super types, okay, you will have the flexibility to pass any of the subtypes so that your code will behave differently based on the actual type passed at runtime without you having to change anything.
Wow, yeah, okay. I get it now, yeah.
Okay, so without having to change anything, because your compiler is guarding you here. Your compiler is helping you that, boss, you can only use the methods coming from animal. And now your right hand side. Later I'll talk about it. When we talk about Spring, I'll tell you that in fact you don't do new on your code at all. I will take this code to super type to nth degree later, and I'll talk to you that you will never do new cat in your code. Everything depends on the super type. Everywhere you will only see the super type. You will never see, but at some point you have to do the actual instantiation. Well, that is done in a separate configuration file later. And the whole dependency injection, big concepts depend on this beautiful polymorphism concept. That's why, in my opinion, this is the most important and one of the fascinating topics of all 3 months. So no worries if you don't get it. I'm stopping it here. Go back, watch it again, try to understand. If not, no big deal. Let's spend more time on in the next class. So don't even worry, because this is going to be the foundation for bigger concepts later. And this is not the only time we'll use this one. You will hear me say from today onwards, you will hear me say this coding to interface or code to super type probably 500 times. I'm not exaggerating. So you will hear me say those many number of times. So don't worry about it, okay? If at all you didn't get it.
I got it. Thanks, Venkat. Yeah.
No problem. Any other questions? And people don't do it though. I want you to understand this. I'm telling you this, people like Rohit and Manikanta, who are actually working, or other people, when you look at the actual code, okay, a lot of people tend to do this one, dog D equal to new dog. There's nothing wrong in it. People do it all the time. People do it. Okay? But the problem is, when you change something here, okay, now you are coding to the most specific type. So your code will not work polymorphically if you happen to use any of the specific methods. If you really need a method in a specific class like a D dot bark or something, D dot fetch or D dot something, if you need it, yeah, you have to use this one. But if you don't need it, you want to use the polymorphism as much as possible. You want your code to behave differently based on the actual type that's provided at runtime. Okay, and we use that not only speaking, we actually use that particular technique. Once I talk about collections, there we'll never do the subclasses. There are a lot of subclasses there, error list, linker list. We'll never do linker list LL equal to new linker list. We always do list L equal to new linker list, because if I want to change my implementation from linker list to some other list, I don't want to touch any code. I don't want my exact animal printer here. This is exactly. I don't want to touch it. You change from animal cat to dog, I don't need to change it, because I'm expecting animal class. So I'm expecting animal, all these animals dad, which is animal. So I don't need to change anything. You want to pass dog? Sure, go ahead. Or you want to pass cat tomorrow? Go ahead. I don't need to do anything. You do it. You worry about it. Because my code will polymorphically work just because of the fact that it will take any of the subtypes. Okay? Okay, so go home and watch the video again and try to understand. I'm sure you'll get it. If not, we'll talk about it again. No big deal. Okay, take care everybody.
Could you please post the videos? Hello?
Yes.
Can you hear me?
Yes.
Yeah, could you please post the videos, this class and the previous class?
Yes. This is already there. It's already been decoded. So this one, I will do it by tomorrow morning.
Sure. Yeah.
Okay.
Thanks, because I have to listen to this again.
Definitely. But meanwhile, if you need to, I'm sure, go ahead and do it here.
Go to the preview.
Meanwhile, just meanwhile, right? Look at this one under super polymorphism, probably here. Yeah. Or one of these. Okay?
Sure. Yeah. Thanks again.
No problem. I'll do it. I'll try to do it tonight itself, even if it's late. So, thank you. Have a good night, everyone.